Hi, I'm Dana, and I wanted to create a little video to show you the Pythagorean Koosh ball game that I created in PowerPoint for use with interactive whiteboards. I guess I'll preface this by sharing with you that I created this in PowerPoint 2007. I packaged it for CDs in order to maximize the compatibility with other versions of PowerPoint, and according to Microsoft, it should even work on computers that don't have PowerPoint installed, but I've never personally been able to test that. I have 2007 at home, which is why this is in 2007, but I used 2010 at school, and it's worked beautifully. Used it many times with no issues. However, if you grab this game and find that compatibility issues do crop up, please feel free to shoot me an email. It's right here on my copyright page, and I would be more than happy to help you troubleshoot as best I can. So also want to let you know that because I've tried to maximize compatibility, the drawback to that is that it could be really tricky to edit this. It seems to open only in read-only mode, and you may have trouble if you wanted to change a question. So I'm going to try to just show you all of the 10 questions that are included in this game so that you can make sure that that's a good fit for your particular group of kiddos. So with that said, I typically go ahead and print off an answer sheet for each student. I just run double-sided copies of slides 3 and 4, and that just creates a little workspace for them. I like to collect it as an exit ticket on their way out the door, just to, hold them accountable for the activity and check for understanding. And of course, you could take a grade on it if you wanted to. So I'm going to go ahead and put this in full screen mode. When you're ready to begin, you just click the start button and you'll see Pythagoras here hanging out in front of a target. So what I typically do is divide my class into teams, typically between 3 and 5 students. Of course, you could do that any way you wanted to, or not use teams at all. It's entirely up to you. I give each team a personal sized whiteboard and a dry erase marker. So each student has their own answer sheet. Each team has a dry erase board. And then I'll ask kiddos that want to come up and toss the Koosh ball at Pythagoras to write their names on a little slip of paper. I'll come around and collect those little slips of paper and put them in a bowl or just stick them on my desk so that I can randomly select names and call kiddos up to come in and toss the Koosh ball. If you don't have a Koosh ball, you can use a bean bag. Sometimes I use like the Nerf guns that have little suction cup darts. That's a lot of fun. There are a lot of different things that you can use. Anything that's soft that interacts with your whiteboard screen is great. If you're concerned about students damaging your whiteboard, you could always have them just come up and touch. It's not quite as fun, but it may be a little safer. I've always told my 8th graders, hey, if I think that you're trying to be excessive, if you're throwing it too hard, then you'll be blacklisted and you won't be able to play these Koosh ball games anymore. We do a lot of this in our class and they love it. So I haven't had any problems, but anyway, what you'll do is have your kid come up, give them a Koosh ball or a bean bag or whatever object you happen to have, and let them have a go. If they miss the Pythagoras here, let's say they hit over here or in the blue space, he laughs and he taunts them, and as you can imagine, the kids get a big kick out of that. But when they hit anywhere on Pythagoras's face here, it triggers that animation, and then a question is presented. So I'll have the kids, work at their tables on their answer sheets to solve this problem. And when a team comes to consensus on an answer, they write that answer on the personal whiteboard. And then one team member will stand up holding that whiteboard with the back side of the whiteboard facing the class. That way I can see that the team is ready to respond, but they're still concealing their answer. They're not showing the class. And then when every team is ready, or when I feel like an adequate amount of time has elapsed, I'll say, okay, 3, 2, 1, and show me. And they'll all flip their whiteboards over at the same time. And that way we all reveal our answer at the same time, and then I'll check it by clicking on Pythagoras there and award points accordingly. Again, that team format is totally optional. You could have your group play this as individuals if you'd like. So then we click on next and you get the same screen again. So I'll just try to go through this quickly to show you the questions that I have. I've got the kind of classic distance across the pond question. We've got a coordinate plane question coming up, I think. I've really emphasized triples with my group of 8th graders. So we have a lot of 3, 4, 5s and 5, 12, 13s. In this question, I've given the area with a model. So I like to challenge my kids to think about the theorem, in a deep and flexible way. A lot of times I'll notice that kids just kind of want to pluck numbers from the problem and, just plug it into the theorem and chug along without really thinking about, what the theorem means and what they're actually given. So I try to test this concept in a lot of different ways. Here they have to recognize that there's a right triangle here embedded within this isosceles triangle, and so they have to use the theorem to find the length of this leg and then realize that because it's being bisected by the height, they have to double their answer in order to get the final answer here. So as they get a little bit more difficult as they progress, I like to use multi-steps. Here we're using the theorem to test whether or not this triangle is right. And there's a nice distance question. So I like to use formats that I think that kind of mimic the standardized testing formats that we use, at least here in Texas. This was something that my kids needed a lot of help with, is what happens when you get squares that don't form a triangle. Can you still use the theorem on those? That's something we practice a lot. And I did make this as sort of a cumulative review, kind of it's a test prep activity. We get tired of obviously using that test formatted worksheets over and over again. So this is definitely sort of an end of unit type of thing. After we've been working on it for quite a while. Here they're given an area, the side length expressed as a square root, so they really have to do some thinking there. They can't just grab numbers and plug them in. And the last question is really the only question that involves serious computation. All of the others are, the computation is pretty easy. It's more of the concept that's being tested. So on the grand finale here, they might actually have to work with some larger numbers. So I did include a hint to look for the triple. So that's the game. When you're finished, there's your ending slide. Okay. If you have any questions, again, please feel free to shoot me an email or post a question at my store. And thanks so much.